is y is equal to cotangent, and if you are a trig master, such as this young man in front of me, what is cotangent really?
Cotangent is 1 over 2.
Yeah, or cosine over sine. So the thing here is, we're going to have a domain restriction when the fraction in the denominator equals 0. So our domain restriction here is going to occur, or one of the possible domain restrictions, there may be many, right? There may be more than one, but this is where we start. Sine of x cannot equal 0. Well, when does sine of x equal 0? Remember our unit circle? Okay, remember that our points are always going to be cosine, comma, sine. And we want to know when sine, so this point is going to be 1, comma, 0, and this point over here is going to be negative 1, comma, 0. Now what's the angle of measure for that? 0 and pi. So x cannot equal 0, it cannot equal pi, and if you were to rotate around again, it cannot equal 2 pi, right? Because this is 2 pi. And if I come around again, it would be 3 pi, and so on and so forth. And same thing in the negative direction. So x can't equal that stuff, I think. Now how could I verify that? Plug it in. Let's see. So now if I graph this, I'm going to graph it as cosine over sine because I don't have a cotangent button on this calculator. So I turn on my calculator, I come in here, and I'm going to say cosine of x over sine of x, graph it. Alright, so it is the reciprocal of sine, so you kind of, or of tangent, so you just kind of flip-flop tangent. Really, kind of. It shifts over a little bit too, but if I were to hit trace and enter in pi, nothing. Alright, so I'm going to hit trace and see where these things are. So 2 pi is about 6.28. Notice that as I get towards 6.28 vertical asymptote. So I think that's right. Okay? Does that make sense to you guys? Does anybody have any questions?
Wait, what do you think is right?
We said that a point of discontinuity occurs when there is a domain restriction. Domain restrictions only occur when you have 0 in the denominator or you're trying to take an even root of a negative number. There are no radical symbols, so the even root business is out. Cotangent is really cosine over sine. So what we're really concerned with is when sine equals 0, because that's when the domain restriction occurs. In other words, sine of x cannot equal 0. Well, when does sine of x equal 0? If we look at our unit circle, the points on the unit circle where the y value is equal to 0 determines when sine is equal to 0, right? So that occurs at 0 and pi. If we come around full circle, that's 2 pi. If I come around again, it's 3 pi, 4 pi, 5 pi. And if we were to go in the negative direction, it'd be pi, negative 2 pi, and so on and so forth. So what we're saying is that we're going to have a domain restriction at any integer times pi, which is where our discontinuities take place. Does that make sense? Okay. So let's just kind of formally note that then. So we would say something like discontinuous when x equals, and I'm going to say k times pi, where k is an integer. And that covers everything, right? That'll cover 1 pi, negative 1 pi, negative 2 pi, all that stuff. Does that make sense? Well, 0 is an integer too, so 0 times pi is 0.
Wait, you said there's domain restrictions when there's 0 in the denominator, or you take an even root of the denominator?
Right. So whenever we talk about discontinuity, so here's the train of thought that you guys should have as we progress in this course, okay? When they say, take the derivative of this function at x equals 2, immediately you should think, is the function continuous at 2? Then what you're going to do is you're going to think, well, discontinuities occur during domain restrictions. Then you're going to look at the function and see, are there any radical symbols? Are you trying to take any even roots? Because that's when domain restrictions occur. And is it a rational expression or a fraction? And then you want to see, will 2 make my denominator equal 0? If it does, then the calculus, you got to do some fancy footwork, right? You can't do the normal substitute in the value to kind of figure out the calculus part. All right? Does that make sense? So that's what we're leading up to.